In this video, we are going to discuss problem based on force acting on a charged particle moving in a magnetic field. If you have a charged particle which is moving inside a magnetic field, force acting on it is given by the expression F equals QVP sine theta, where Q is the charge of the particle, V is the velocity, B is magnetic field, and theta is the angle between the velocity vector and the magnetic field. The question says, a beam of proton travels at 3 times 10 to the power 6 meters per second at right angles to a uniform magnetic field. If the force acting on electron is 1.9 times 10 to the power negative 19 Newton, what is the magnitude of the magnetic field? So let us first write down what the question has given us. They have given you the speed of the particle, which is v, 3 times 10 to the power 6 meter per second. They have given you the angle between the velocity and magnetic field. Right angle means it is 90. Then I have the force acting on the electron, 1.9 times 10 to the power negative 19 Newton. Since the charge mentioned is electron, charge of electron and proton is a constant now, and the magnitude of that charge is 1.6 times 10 to the power negative 19 Coulomb. This number they don't mention in the question. They just use the word electron and proton. So you must know that whenever electron and proton, the elementary charges are mentioned, the magnitude of that charge is given by this. We need to find what is magnetic field B. The rule says F equals QVB sine theta. I need to find what is my magnetic field B. So if I want to find B, I need to get rid of all the terms which are attached to B. And since all of these Q, V, and sine theta are multiplied to B, when I move them to the other side, I need to divide by them. So we rewrite the expression of B as F over QV sine theta. So in this kind of equations, where everything is multiplied together, whichever quantity you want to find, you can hide that quantity. So let's say if I want to find velocity V, I can hide that quantity and divide force with whatever term is left. So V will become equal to F over QB sine theta. If I were to find Q, I will hide Q and divide with whatever is left. So Q will become F over VB sine theta. This is how you rearrange the term to find whatever quantity they have asked you in the exam. So let's continue. I will substitute for B. F is 1.9 times 10 to the power negative 19. Charge is 1.6 times 10 to the power negative 19. V is 3 times 10 to the power 6. Theta is 90. And when you solve this, you get the value of magnetic field as 3.96 times 10 to the power negative 7 Tesla. Let's discuss another question similar to the previous one. A beam of electron travels at 3 times 10 to the power 6 meter per second through a uniform magnetic field of 4 times 10 to the power negative 2 Tesla at right angles to the field. How strong is the force? So here my charged particle is electron and it is moving at right angles to the beam. So let's write down what we have been given. I have the speed v. Then I have the magnetic field B, 4.0 times 10 to the power negative 2 Tesla. The question mentions the charge as electron, so we know the magnitude of charge on electron is 1.6 times 10 to the power negative 19 coulomb, and the angle theta, since it is right angle, will be 90. I want to find what is the force. So this is a pretty straightforward question where you just use the rule of force and plug in the values. F equals QVB sine theta. Let's substitute. Q is 1.6 times 10 to the power negative 19. 3 times 10 to the power 6. V is 4 times 10 to the power negative 2 into sine 90. And when I solve this, I get my value of force as 1.9 times 10 to the power negative 14 Newton.